Hello, can you hear me? Can you hear me? Please, if you can hear me, please put plus into chat. So sound is okay. Okay. Okay, first I will answer two questions. Will be there a screen recording? Yes, it will be available, as I was assured by technical guys, but I don't know where exactly it will be put. I hope they will tell you in chat or somewhere, maybe by email. Now I hope you can hear and see me, and today we will talk about probability and statistics in master program in finance. Especially we will talk about master's program of ICEF in finance, but in general we will talk about probability and statistics preparation for master programs. I am provided with 3 slides by our administration guys. I will cover them just in a couple of seconds, but first let me tell you a couple things about myself. So 3 things about me. First thing is I'm teacher. I'm teaching from student years. I teach the school students, but now I'm teaching students in bachelors and masters, teaching mathematics, probability and statistics for overall, I believe, more than 10 years, and that's what I do. That's what I like to do. Several years I was voted as the best teacher of the year, something like this. Second story is math. My math background is from Moscow State University, department mathematics and mechanics. For those who are not Russian, who are from abroad, it's the best mathematical education in Russia possible, at least for the moment. I graduated about 10 years ago. And economics, my background is from New Economic School master program in economics, and that time I took it, it was the best. It was 211. Who know, it was Sergei Guriev's time, so it was the best time for New Economic School. It was the best place in economics. Unfortunately, you know the story now. Now I'm teaching at High School of Economics, ICEF, International College of Economics and Finance, bachelor and master's, probability and statistics. Most of we will do with it, something with it. So our topics today about preparing probability and statistics, probability theory and statistics, and first, one important thing is that I want to say is that there is no magic pill. You don't have the story when you can get, I don't know, take 1, 2, 3, and then you'll have success for sure, 100%. So I cannot tell you do these 3 steps and you will for sure enter the program and will survive and will finish and graduate with excellent results. That's not a story. It really depends on the person. I hope you understand it. Some people, even without mathematical background, but due to their abilities, due to their character, due to their I don't know, something devotion, can still manage, and some people may be more prepared, but without it, maybe will not. So it's not a magic pill. Please be sure not to think that's some magic pill. And now 2 topics we will cover. First is the usage, why probability and statistics are needed in economics and finance. And the second story is how to prepare for economics and finance for master's level. And usage is the following. First story is instead of uncertain answer, probability theory allows you to do some numeric answers. Instead of intuitively, this is better, this is worse, this is more likely, less likely, you can have probability, the number, one number greater than another. Okay, this is more likely, more probable. I believe it in this more. Then lack of information you can model by randomness. So if you don't know something, you can say, okay, let it be random, and let's model it, let's work with it, not just, I don't know, something more about it. Pieces of information are conditional probabilities, and the most important thing of all of this is assumptions and conclusions are separated of each other. Second story is usage of statistics, and this is about calibrating models, your models, your assumptions based on observed data. So you have some model, and you can see if it's okay for your data or it stops working, and now you need another model. You can justify the choice of model. You can say, okay, I choose this model because of that, not just because I like it. You can catch the model when model fails. So you can see, okay, my model worked a lot for me, but since this moment, it stops working. And also, the most important is that assumptions and conclusions are separated. Okay, let me see how these two stories work in an example. Consider the following example. You have a bank, and of course, bank has deposits and loans, yeah, and credits. And but let me not read all of this story. Let me not read all of this story and simplify it. Long story short, we have a bank. It has clients who make deposits and have clients who take loans. What happened with this bank in 1 month? What will happen? Could it be that the bank will be bankrupt? Tell me, please, could it be that some bank be bankrupt in 1 month? What, for example, could lead to it? Write it in chat. What, for example, could lead that the bank in 1 month becomes bankrupt? Yeah, for example, if, for example, very artificial example, but everyone will take who put deposit, try to take it back. So say, okay, I put my money to your bank, now I want to get it back without any percentages, without any returns, just want to take all my money back. Bank just does not have this money. So the main question, could it possible happen that the bank will be bankrupt in 1 month? And the answer is yes, it's possible. Okay, could it be possible happen that bank in 1 month or one year will get some profits and will survive? Answer is also yes. So if you ask the question, what will happen with the bank? This one, what will happen with the bank? The answer is it can be anything. It can disappear, it can be bankrupt, it can earn some money in 1 year time, it can do whatever. Will the bank be suspended due to violations of central bank? Whatever. It can happen or not. And as you can see, we have answer like uncertain. Anything could happen. Not good. And we can say that intuitively it's very unlikely that everyone will took the money and bank will go bankrupt. Intuitively it's unlikely. It's very rare event, but no numbers now. You can say just, I don't know how many people will took money. I don't know. And what's the story? The story of probability theory is I model my bank. I say how many clients I have now, how many people with deposits, what is the amount of deposits. I know for sure how many credits I give, how many loans I give, my bank gives. I know all of it. And I model as a random unknown number how many people will took deposits back in 1 year time. What does it mean? It's some model, and I believe that with probability, some probability, nobody will took the money. With probability, some probability, one person will took the money, and so on. Once I have this model, I can say much more. I can say that with this probability, bank will go bankrupt. With what? May you hear something? Please tell it more clear what you're meaning. Okay. With this probability, bank will go with some profit. With this probability, bank will go with different profits. So once you will have the exact model, you will get numerical answer for probability instead of intuitively. You will say that number of people is randomly distributed with some distribution and so on. Okay. The most important story about probability and statistics is separation of assumptions and conclusions. Let me show you this in a different example. Consider the maybe some little tricky story, but that's a fake story, of course. You and your friend are going to visit a bar, and maybe you want to drink some beer, or maybe not beer, and then you want to drive back home by your car. So your car is nearby, and you'd like not to push your car here. You want to take it back with you, your home. So you, of course, will not drive drunk. That's for sure. You will drive only sober, not drunk. And now consider that you is not just one person, but the company of two departments. You have a fun department in your personality, and you have safety department. And your fun department say that either both of you will not drink, and then you will have fun, both of you, or both of you will drink, and you also will have a fun. So your fun department prediction, according to this story, is 100% you'll have fun this evening. Your safety department assumes that either you will drink, but then your friend will not. Either your friend will drink and you will not. Either nobody will drink and everyone will be sober. It means your safety department believes at least one person will be sober. So 100% that you have go home safety and take your car. What's the problem here? That every department make conclusions considered to just this department. Fun department make conclusion about fun, safety make conclusion about safety, they make separate conclusions, and overall your plan is 100% of fun and 100% of safety with your car. Time will show that your plan will fail, of course. What's the problem? In fact, it would happen if the fun department has power. It means you will do what fun department tells. Either both will drink, and if both will drink, you will not get back with your car. If safety department has power, it means all of the evening you will discuss who will drink and who will not, and no fun at all, most likely. What is important? To see the implicit assumptions that fun implicit some probability of drinking. Let me do it 50%. 50% we will drink, 50 no. And if we will drink, that 100% that we will drink together, that's what fun department assumes, that we will drink together, given we will drink. Safety department has different assumptions behind it, because 50% we will drink, but then if we will drink, mutually exclusive drinking. So either me but not the other guy, or the other guy but not me. So different assumptions. So if X is a random variable that is one when there is a problem with connection. What kind of problem? Tell me, please. And private message. I know what is private message. Problem with connection. Okay, put minus if you have problem with connection. For me and for technical support to see if really this is a general problem or not. Put minus if you have problem with connection and something is bad, slowing down or sound or something. I don't know. I'm just really seeing, I'm just really watching at camera and can do nothing to check. Okay, so I believe everything is okay. And try, Pauline, try to restart or do something. Maybe restart browser or just restart the page. Okay, let's go on. If x is a random, which is equal to 1 if you drink and 0 if not, and y random variable about your friend, 1 if he drinks and 0 if not, then fun means they are correlated with 100% correlation. X is 1, y is 1. X is 0, y is 0. I drink, friend drink. I not drink, me not drink, friend don't drink. But safety assumes negative correlation, minus 100%. It means if I drink, friend for sure not drink. If I not drink, friends for sure drink. Something like this. And they cannot be both right. It means assumptions of departments are controversial. They contradict to each other. It means our plans will not work. So what is important? That common assumptions, then conclusion may be true if different assumptions in each department will not be true. Conclusions will not be true. Why was this speech about? Because when you work, not learn statistics, but when you work in real company, if you work in real company, in business, whatever, you will, in corporation, you will have many departments. And everyone will like to make conclusion about their own business, their own story. And that's very important that every department will try to argue its conclusions are right and these conclusions are important. Every department will talk in a separate language about their conclusions. What is important to make all of these conclusions, all of the job, to have chance to be done. It's important that all conclusions be not contradictory. But people of one department will not discuss conclusions of the other department. Just people from one department don't care about conclusions of our department. So what do? We separate assumptions from conclusions, and we negotiate assumptions. For example, before this evening, we will negotiate and discuss that we either together will drink or together will not. And once we decided this, then safety department will know that probability of safety is not 100%. It's in fact safety going back with your car is only if you both not drink, so it's only 50%. But fun is 100%. Or you can negotiate the other story that exactly one of you will drink. In this case, safety is 100%, but fun is 0%. And you will know it from the start. And all departments will conflict only about assumptions everyone can talk about. And then conclusions are derived formally. It means once we believe and decided and agreed about assumptions, we for sure know that if you believe in these assumptions, you believe in conclusions. That's the story about why this is important in practice. To have the common background, the common knowledge, and the common assumptions behind the whole story, the whole job of the department. And then make conclusions based on it. But we negotiate assumptions, of course. Either we believe that we will do like this or not. Either we believe we will have a lot of clients this month or we will not. But if we believe we will have a lot of clients, we know it will have a lot of sales and a lot of costs to hold these clients and a lot of people to talk to these clients and a lot of things. So one assumption about lots of clients will lead to many others. Okay. Example 2, I maybe will skip it. It's about advertising. I will just cover it very little. You have 2 advertisement campaigns. You just show your banners of one banner and show your other design of banner. And one banner gives you 40 clicks and another 30 clicks. And of course, person who I don't know, who painted that banner, who designed the banner 1 says, oh, my banner is much better, it's 40 clicks. Use just my banner, pay just me, and I will work a lot and draw you more banners. But maybe this 40 is due to randomness. Maybe this is due to randomness, and it's just it's just the same effective. Just these 2,000 people happen to be such guys who more like this. So for 5 million people, maybe A2 design will be better, or maybe they will be the same good, or maybe A1 will be better, and we don't know. And every designer will say, I'm right. First one will say, I'm much better. Second one will say, no, I'm at least that good. It's just unlucky shot. And we need algorithm that allows us to judge, to say, okay, this 40 and 30 is not just due to randomness. It means A1 is much better, and we will vote for A1. Or this algorithm can say, 40 and 30 are due to randomness. It's not too much difference, not significant difference. So maybe guys work same well. Maybe both designers are worse, continue working. And that's the story. How to prepare such algorithm, how to judge, so not to make conflicts after all. So we need some good algorithm. And this is the story of choice of the model, of choice of parameters, and this is the story statistics works with. We have data, we made 2,000 show-ups and get 40 and 30 as results. Based on this data, we find out which model is better. This is statistics works with. How to prepare? In general, how to prepare splits into 3 parts. You need to learn concepts of probability and statistics. You need to learn language, not English language. I'm talking about probability and statistics language, of course. And you need to practice in problem solving. At what level? Of course, every one of you have learned some calculus at university, at bachelor's. Every one of you learned some probability and statistics at your bachelor's. And it depends how well it was taught to you, how well you have learned. So I don't know what your skills are, in fact, now. For example, one thing I provided is the test. Take plus, put plus who managed to get this test, ICEF test.zasorian.ru, and obtain some result, whatever result it is, but just at least run it and look at it and do it. Put plus if you tried ICEF test.zasorian.ru and managed to get some results. I don't know, even 0 results, but some result. Put plus if you tried it. If you get the link before this webinar and try it. Okay, so as I can see, nobody in fact tried it. Yeah, I can see minus, but I cannot see any pluses. It means nobody tried. Okay, that's a choice. It was not necessary. It was not must. It was just the opportunity. I just want to tell you that this link, I will print it. This one. This link will work today and tomorrow, and then that server will be shut down. So you can practice if you like today and tomorrow. Of course, this is not just super-based level. Some tasks are super-based, some tasks are quite advanced here. But you can see your level. You can see how much you understand the probability and statistics. And after the course in master program, every one of you can solve any or I mean all of these tasks. So it means it's like base result of master finished probability and statistics. So you can see how much how much far are you from this result. But now let's talk about how to prepare, where to get materials. First of all, if you're Russian, you know that probability and statistics in Russia suffer a lot, and not as good and not as advanced, not as developed as calculus. So historically, we have strong calculus because it was at schools, not elementary, but at schools in USSR, and all teachers know calculus well, and so this is the story. But there were not probability learned in schools, only at university in USSR. So now it's in schools, but not as good as needed. That's why our Russian level in probability and statistics is not as high as many abroad schools. Calculus, Russian calculus, just people even entered bachelors, they are good, they are strong, competitive to the world's level. So if you want to learn from probability and statistics for bachelors, there are two problems. If you learn it for math, for example, mechanics and mathematics or MIPT, whatever, it's too sophisticated and not applied. That's not what economists needed. For economists, it's too easy usually and out of league of master level. So master's program requires high level, and it will provide you high level, of course. If you look at bachelor's and probability and statistics courses, second best option you can do as you can look at modern courses for bachelors in economics in top places like Harvard, Stanford, MIT, whatever you like. Any course of those, most of them are available via internet, so you can look at tasks, you can look at lectures, video lectures or text lectures, understood what's going on, and learn your level to just quite strong enough. And sometimes they are very, very clear and super understandable, super easy in understanding those courses. Second best is to learn in top places in Russia. I mean, High School of Economics or MSU Economics faculty or whatever. Top choice is top universities in US, Harvard, Stanford, whatever. So online you can look, you can learn, and you will know probability and statistics quite well. If you go too far, you maybe will cover master's level as well by your own. It would be super easy then for you to learn it in masters. Excellent grades, whatever you like. So for the start, if you have weak background in probability and you try this test, I provided a link for you, and you cannot solve almost any tasks, like, I don't know, first 3 tasks you can solve and then 20 you cannot, like this. Then you can look at courses in Coursera for beginners, in Russian, in English, whatever you like, but look at courses for beginners in probability and statistics. You can look at books for beginners. In Russia is also okay. They will not be in our league, but for the start, it will be okay, and maybe it will be enough for enter, and then it will be a hard job for you to catch up, but then you will be in level of our master program, which is quite great level in Russia. Okay, what materials do we have? Coursera and all other online, like they know, mass courses environments, world's top bachelor's courses like Stanford, Harvard, whatever, books, of course, and also you can learn from videos. Videos are good. They are very intuitively understandable. They are fun, but they are not integrate. It means it's just one topic. If you missed just one topic, use YouTube. If you miss probability and statistics, logic, and the whole story, what we're doing then, what is the whole steps, all steps, one YouTube video about one topic will not cover it. So then use the course in Coursera, in books, in university, whatever. For example, if we look at Coursera, you can look Khan Academy course. Tell me, please, if you can see my screen and my PDF. Oh, stop. And my PDF here. Okay, you can see. Great, thank you. So I hope you'll be provided with this presentation because of these links to the resources. So I link random variables, and it's loading. Khan Academy. Okay, it's not support Internet Explorer. Okay, then let's go Chrome. I hope Chrome is okay. Yeah. So what's the story? You open a introductory course in sampling distribution topic, just like introductory course, probability and statistics. And for example, you go, I don't know, whatever. Okay, let me look not at sample distribution, but at random variables. How can I do it? Statistics and probability. Statistics and probability. Random variables. Okay, for example, discrete random variables. If you learned probability and statistics, you easily can do practice from the start. So you run practice, like mean expected value of a discrete random variable. And you go for it. And you look, okay, I have random variable x equal to 0, 1, and 2 with probabilities 91%, 18%, and 1%. So how to find mean? You must multiply 0 by 0.81 plus 1 multiply 0.18 plus 2 multiply 0.02. So if you got it, you understand the probability would be 0.18 plus 0.02, 0.20. Why this not work? Oh, we need to calculate mean of m. Okay, m is, I will not make it so fast. You multiply this number by 81, this number by 18, this number by 1%, and that you'll get mu, check it, and see, okay, I'm now right, I'm okay, I got that topic, and go further. If you do not understand, you look, watch a video or use a hint. So get a hint or watch a video. You go to video and learn. So what's the idea? You go through this course, I don't know if you can see me, but you go through this course looking videos if you need, solving the tasks, and get all of that story. And then you understand, I got random variables, I got probabilities, I got I know, tests, I got confidence intervals. That's about it. That's like introductory story you can do. This video explains how to find the expected value and how to solve these tasks. Okay, let me then close it and get back to the story. Another story is for Russian. It's courses in Coursera. For example, it's course of Andrei Regorodsky, who is super great. If you know, he is chief in research in Yandex. He is a president. He's got some presidential, I don't know, grant for a lot of money, so it's Putin's grant. And also he's a professor, a very young professor. He was just 27 professor in Russia. It was super young. So he's great, and he explains quite clearly difficult things. So you can look a little bit old school writing in the blackboard, but he's great, so you can listen to this and get it. Okay. Also, there are courses in English in Coursera, for example. If you want advanced level, look at stochastic process course. You go for it, and you can see that this is advanced course, which is free, of course, and you can understand more deeper, much deeper, the story that you learned. Types of stationarity, you can get more difficult things. But it's not the base. It's for those who already quite prepared in probability. Okay, what else can you do? You can look at Harvard, at top places, for example, Harvard. And if you look at requirements, just open the file and see what courses are required for every economist in Harvard. You will observe that there is one course in probability, which is a must for all economists. So if you are economist bachelor in Harvard, so undergraduates, you must learn the course which is known as STAT 110 probability basic course. It goes to statistics. It go. Can you see? I'm not sure if you can see my my cursor. I'd like you to see it. I hope you can see my cursor. If not, tell me minus, please. Yeah, you see. Okay, great. Then this is the basic course for all economists in Harvard, for all bachelors, not masters, bachelors in Harvard. It goes to linear models, to econometrics. It goes to statistical inference. It goes to a lot of things, like they say Wall Street, like they say life science, design foundations, whatever. It's like for everything, so it's basic. Okay, and once you understood that Harvard basic course is this course, what you can do about it? You can look at list of courses, and you can find, for example, that there is YouTube free open statistics 110, this statistics 110 course with video lectures. So you can catch up with guys from Harvard. If you learn statistics in your bachelor, maybe it wasn't taught as well as in Harvard. Maybe yes, maybe it was much better than Harvard, I don't know. But if not, you can do it. And it's a lot of story. It starts, for example, from the very beginning, when in the first lecture, the teacher just started with the definition, naive definition of probability. When he said that probability of event is just naively probability of event A is just, and the lecture is much slower than me, as you can see. It's one more important advantage. So the lecturer explains, number of favorable outcomes divided by number of all possible outcomes, like that. And more than that, the lecturer is very good. He shows examples, flip coins, and the most important, he provided the assumptions. Here is the assumptions, so you can know when this formula is okay and when it's not. So it's okay only in these assumptions, if all outcomes equally likely, if you can justify it. So that's the story. From very start, it goes to a lot of material you can learn easily. If you don't remember how to calculate continuous distributions with integrals, maybe you haven't learned it in bachelor's, continuous distributions with integrals. Maybe you learn it but not understand it too much. But you can see, full screen please, you can see from a to b as an integral from a to b f of x dx. And then examples, how to understand it, how to solve it. You can learn here, then go and test yourself in those quizzes, whatever you like. And this is Harvard, this is top place. Believe me, I looked through this course, I watched it. It's really very competitive with our master program. It's undergraduate course in Harvard. So it's quite good. Of course, it's not covers everything from our master program. Our master program is master program, but it's good. Okay, that's one story. You can go and look Harvard course. More than that, you can look at handbook, the standard book they learn. And it's also available, it's also free, it's also can be opened just from the scratch, just immediately you go and look that. And that's no problem to learn to review your bachelor knowledge, to improve it. Introduction to Probability, the course for the Harvard. It's quite slow. Naive definition of probability. Remember that was in lecture. So random variables, distributions, whatever you like. Also, if you want to practice, if you want to learn how to do it, you can open solutions of via tasks and do a lot too long. Math review handout. Those stories you can learn. If you want more advanced course in statistics, you also can learn from Harvard. Presentation open, so you'll be able. Yes, I will provide this presentation to technical team, and I really hope they will send you this presentation by email, or maybe publish it somewhere, or do it with something. Because really, I haven't made it beautiful, but I have made it useful. With such links, I looked and searched these links quite long to find out all these links to all Harvard, MIT courses, and all other. MIT courses, no videos, unfortunately, in MIT available for free, but you can look at handbook and lectures and problem sets. It means you can open the problem set and find out how in MIT, in bachelor's level, they learned maximum likelihood. So they consider Poisson distribution and try to find maximum likelihood of unknown parameter. If you learned in bachelor statistics well, you can do it right now. If you don't learn it too well, maybe weaker course, you can learn in lecture, in video of Harvard, and then learn it. And those tasks also have solutions. That's good. Stanford course. Stanford has very good course in open it. Stanford had very good course in statistical inference, in statistics. So it's not probability theory, but this is statistics. It's about tests, confidence intervals, method of moments, maximum likelihood. I'm not sure if you can see, it's too small, but you can open it later and see. It's statistics course, very good. With slides, with tasks, with solutions, so you can learn. Because in MIT and Harvard, just probability courses are good. Statistics is not available in free version. If you find okay, but I haven't found, looked for a long time. So they have good handbook in statistics. That's a story. And they have probability and theory course with homework, exams, solutions, everything. In Stanford for many years, this is for, as far as I remember, not sure of the year. Somewhere it was written, I'm not remember now. Okay, homeworks in statistics, solution in statistics. Now, if you want to learn not by courses, but by books, what can you do? I looked through plenty of books, and as I told you previously, they mostly from math, so they are very advanced and not applied, not good. Some of them for economists, bachelors, super simple, super easy, not good enough, not hard enough, not about it. And the good books of good level of difficulty and good and applied, not just theory for theory, are those ones. It's probability, it's introduction to probability. I believe this link will just open it online. Really hope so. Yeah, this is Harvard basic book for Harvard bachelor's level. It's very good. It's very simple and clearable, understandable. If you missed some concepts, just read it and understand it. And they have also tasks inside and solutions of these tasks. Okay. Also, one more, probability and statistics. For those who learned in high school of economics or MSU in Russian, it would be quite familiar, the book of Hawk, because it's more, okay, it's PDF, will it be opened? I don't know. It will be more for for people who learned in Russia, because our economics statistics is more likely to this course, and the level is good enough, and the coverage is good enough, and it's maybe not as easy as Harvard, not as clear as Harvard book, but quite clear for those who learned in Russia. Okay, that's it. And as usual, it has probability and distribution, random variables, discrete, continuous, expectations, two random variables, and for two random variables, it would be an integrals and discrete case, everything you need. It has also confidence intervals, method of moments, like consistency, maximum likelihood methods, everything that is needed. Good enough. Okay, what else? For statistics, it's a very good book. John Rice, Mathematical Statistics and Data Analysis, and also Mathematical Inference. It's MIT and Stanford books, so very clear. If you want Russian, you can look at Gmurman, теория вероятности, математическая статистика, руководство по решению задач, соответственно, задачи, решения, все, что вам нужно. У Черновой, это Нижний Новгород, вышка, теория вероятностей, отличный курс лекций, тоже очень понятно. So if you're Russian, you can look at this story and it would be clear for you because it's Russian, maybe easier. But after you look through it, please go back to the best practices from the world. Okay, what about videos? I choose for you some fun videos. For example, if you, I don't know, whatever, confidence interval interpretation. If you've missed what is confidence interval, not how to calculate confidence interval, but how to interpret it, you can just look and see how I don't know, will it work? Please, what? We found confidence interval 4.8 and 22.7, and what is the meaning of this interval? I'm not sure if you can listen, if you listen the voice from this, as far as I was told, you cannot hear the voice from here, you can just hear me. But the guy clearly explains what does it mean, and if you will repeatedly do something, we will get these kind of intervals, and then he draw the graphs and explain everything. So if you missed interpretation of confidence intervals, 7 minutes you understand every detail, how to calculate, how to interpret, everything. If you missed continuous PDF integrating, it's also no problem. It's YouTube channel JB Statistics, quite good channel. They draw a PDF, they explain the probability x greater than 3 is just area from 3 to infinity, but here it's from 3 to 4 because the graph is like this. And then this area, of course, is greater than 50% because it's greater than the left side. So the total is 1. A general case, they explain how to find, what integral should you write, how to find it. Everything is explained clearly. So if you miss topic about continuous distribution, you can learn here. Lot of story, how to find normal distribution, whatever. Also, there are lots of cheat sheets in probability and statistics, Harvard, not Harvard, everything. So if you look at cheat sheets, it's like, no, it's like, I can see it. It's like very dense amount of material. All formulas in 1, 2, 3 pages with graphs, with explanation, with PDF, CDF, integrals, everything put variance formulas, whatever you like. I know, covariance properties, how to simplify covariance, everything you want to know, central limit theorem approximations, everything in very short, so you can review it here and see if you miss something, if you haven't learned something for some reason, whatever, in bachelors. So this is the story. Okay, you can review bachelors before bachelor's exams of Harvard, as far as I remember. Okay, so I believe I provided you a lot of information for this 1 hour, for this 60 minutes. Let's review. First, we talked about our program, which is good, which is the best program in Russia in finance, economics, master program. For now, it's the best ICEF masters in finance. So please come. It's good. We have good teachers, good PhDs in research, good practitioners who are from practice, and so please come. Second story was about why probability and statistics are important for us. It means we discussed the separation of assumptions and conclusions. And then we discussed how to prepare. So we discussed online courses like Coursera, like Stepic, like Khan Academy, whatever. We discussed modern universities, the best universities courses like Harvard, Stanford, MIT, with YouTube videos, lectures, with tasks, with opportunities to solve it and to check yourself. And very few but very good books I provided for you. And some fun videos. What does it mean? Very separate topics. If you missed, if you don't know or want to review and get it better, you can look at separate videos and find out. But not for integrated knowledge. If you want to review everything, please use books or courses, not just one video. Okay, that I reviewed all I talked for 60 minutes, and now 60 minutes end, and I'm ready to answer any of your questions. So please ask any questions. I try to give you any answers like this, so I can read in chat if you will write any kind of questions. You're welcome. You're welcome. You're welcome. Join us. You can ask more questions, any kind, get more answers, have more webinars, lectures, and top speakers. One question about math. Okay, welcome. You're welcome. Interesting. Can I see how many people do we have? Okay, not too many, just 8 people. Okay, no problem. Which way of preparing is better? For the math, English, Russian. If you're talking about linear algebra, actually it's not my place. Nah, yeah, my place is about probability, statistics, not about math. But okay. If you talk about linear algebra and calculus, USSR, I mean Russian traditions are very good. So it means books in Russian in linear algebra and books in Russian in calculus are very good. So you can prepare in Russian and you will miss nothing. So it would be a good way to prepare in Russian if you are Russian. Welcome. No questions if you have. Any people, any questions, you're welcome. Thinking of everything is clear. That's good. That's good. That's quite a lot of information and really, you know, I wish I would have such opportunities when I graduated myself. That it would be, I wished if it was available YouTube course from Harvard for free, and tasks from Harvard, and answers from Stanford, and everything. Oh, that was, so I can capture everything then and know that I'm best because I can capture everything. So, okay, I will wait maybe for 1 minute, and if no one still have questions, I'm saying bye, and thank you for coming, and inviting you once again to join High School of Economics Institute, International College of Economics and Finance Master Program in Finance. And see you in my lectures and classes during your study at High School of Economics. But I'm still talking because I'm waiting for your questions for last 30 seconds. If you still have, you can do it until we will finish this webinar, which was a pleasure for me. It was my first time webinar for High School of Economics program for High School of Economics system. I really hope helpful. Yeah, I looked a lot for these materials to collect it all in one presentation for all best courses, books. Oh, and look through many books. So this webinar's material will be sent to emails. If it will not be so, where can I write to ask for it? You can write, and I hope you will write anyway, to these guys. Just give me a second to find this slide with email of our guys. This email, as you can see, that email I got. This email is about people who will respond for if you will come to us, if you will enter our program. So they will, of course, send you, if you like my presentation, answer any questions about this webinar, about the program, about whatever. So this is email. They will respond any of your questions. Okay, so I wish you all the best. I wish you great week, great year, and see you next year, our program. Goodbye.